Hello everyone, my name is Naytitorn Chaovirachot and this is my project. It is ARL Link schedule analysis and visualization. The description, the application is a data exploration and visualization tools that allow users to interact with a data set containing information about ARL Link time schedule. And then you can filter the data set based on various criteria such as the train station, day of the week or date, and select which column of date to display. Yeah. So let's look at the program. Here we start, and this is the default graph, and here's statistic and the option. You can choose the option. Yeah, if we choose name substation to be Lat Krabang, yeah, it's gonna be Lat Krabang, and then it's gonna update. And if we click histogram, it's gonna update to the current data frame histogram. So if we select another one like Payathai, it is gonna update. Let's see. Here it update, and then we can select another one to plot. Then we can choose more options. Yeah, so this if we choose both options, it's gonna have the name of the station and then the day of the station. And then we can choose the plot graph here. Choose the plot graph. So let's look at more examples. Here can use the scatter plot to do. Yeah, so that is my program. Yes, startup. And yeah, if we select only one option, it's gonna look like this. And then all option is here and here. The data that I use is CSV file from this website. Here you can take a look at it. And this program requires Python version 3.10 or higher to run, and requires these libraries to run. All of this you can import directly except NumPy and Pandas, which you need to use pip install to install, and then you can import it directly. The design of this program is composed of composition relationships and some with inheritance relationships. And then this program tries to separate each class responsibilities. So ARL manager only manage the data frame and not plot the graph. Here let's look at the full one. So here is the GUI and then the facade, and then the manager, and then the facade with all of this. And all of these options maker is inherited from the drop-down maker. And we have visualizer. They are composed of two types of plotter. Here. And presentation layer is like about GUI, and then business is about data management. So the sequence diagram here have main and GUI, and then this here is main. If it's main, and then the main called the GUI. So it calls and then it initialize the class and set up drop down and update drop down and add default graph and go to main program. Go main loop. The design pattern I use facade design pattern to hide complexity. The main class and area manager class, and then hide all of these GUI options in the facade. Here. And the graph algorithm I use, and here's the problem. I use the graph algorithm to determine the path with lowest passenger from station A to station B. For example, if I want to go to station A4 from A1, there are many ways I can go, but there's always a path that has the least amount of passengers. I can use the shortest path algorithm to find as well. The vertices can be represented by each 10 stations, so there are n stations. Edges are represented by the paths between each station, there are m paths. edges are unrelated. And the edges have weight, which is associated by the average of inbound and outbound passenger, which is non-negative. Given an unrelated non-negative weight graph G and vertex S in G, we need to find the shortest path from vertex A to B. And we can solve this problem by using non-negative jigsaw algorithm from A to B and output the path array. And this algorithm runs in O E log V, which is O M log N time. Let's look at what my network card look like. Here I filter my data frame and then use this data frame to create a network graph, and then I use the shortest path algorithm on it, and I plot the graph and make the shortest path highlighted in red. So here if we have source A3 to target A8, you're gonna highlight A3 to A8 here. And I think that's it about my project. Thank you for listening.